Welcome to qnawire.
Hi, so over here we're dealing with the following reaction of solid zinc plus HCl. In this case, we're going to require two equivalents of HCl in aqueous medium, and this is going to produce zinc chloride in aqueous media plus hydrogen as a gas. So this reaction is quite common whenever we want to do an experiment on the chemistry lab, right? So we're starting with 1.05 grams of zinc metal of zinc. We're told that the hydrochloric acid is going to be in excess, so the reaction is going to be measured with respect to the amount of zinc that we have. So the amount of mole of zinc is going to be related to the molar mass. We need to divide by the molar mass, which is 65.38 grams per mole. Grams in 1 mole. So the amount of zinc that we had is equal to 1.606 times 10 to the minus 2 mole. So, with the information given, we want to know what is the amount of heat in joules transferred in this reaction. We know that this zinc is going to be reacted with 1.1 molar HCl and an amount of mass equal to 128 grams. In this case, we're not given the density to calculate the volumes, and with that we would be able to calculate the amount of mole of HCl, but since we know that this was in excess, we can simply state the final mass as 128 grams. Now, the total mass of the sample is going to be equal to 128 grams coming from HCl that we added, plus 1.05 grams coming from the zinc that we had, and this is going to give us a total value of 129.05 grams. The amount of heat that we're going to get is going to be related to the heat capacity. In this case, we're told to assume that it's equal to 4.18 joules per gram degree Celsius, and it is going to be related to the delta T, which is final temperature minus initial temperature. We're told that the final temperature is going to be equal to 22.97 degrees Celsius, and the initial is going to be 22.58. So delta T is equal to 0.39 degrees Celsius. Remember that in this case we can keep it in Celsius because the change of temperature in Celsius and in Kelvin is going to be the same, because we have a relationship that only depends on adding one number when we transform from Celsius to Kelvin. So both of them are equivalent just in this case. In any other thermodynamics problem, always convert to Kelvin. Now, to know the amount of heat transfer due to this reaction is going to be equal to mass times heat capacity times delta T. The mass is 129.05 grams times my heat capacity, 4.18 joules per gram degree Celsius, times delta T, that is 0.39 degrees Celsius. So the heat in this case, as you can see, is going to be in units of joules. Grams with grams cancel out, degrees Celsius with degrees Celsius. And the heat coming from this reaction is going to be equal to 210.377 joules. Now, if we want to know what is the amount of heat transferred in this reaction in terms of the enthalpy, what we want to do is divide Q by the amount of mole of reaction that occurred. In this case, it would be 210.377 joules divided by the amount of mole that we calculated earlier. That is 1.606 times 10 to the minus 2. 606 times 10 to the minus 2 mole. This gives us 13,099.46 joules per mole, or which is approximately equal to 13.1 kilojoules per mole. So this would be the enthalpy for the reaction. It is an exothermic reaction, so that is why we're going to have a positive value for delta H. Sorry, a negative value for delta H. Remember that over here, delta H for the reaction would be with the negative sign. the heat that is going to be absorbed by the system is going to have the opposite sign per mole of reaction. So delta H negative. But the answer to the actual question, what is the amount of heat in joules transferred in this reaction according to the quantities that were given to us, this is going to be this one, Q. So that would be all. Thank you very much and have a good one.